Hello, I am Shime. Today we will see how to employ t-tests using Excel built-in function. Let us go. We can use descriptive statistics like mean and standard deviation to summarize data. But to determine whether the independent variable has a significant effect on dependent variable, we need to use inferential statistics. One of the simple and important inferential statistics t-test. We can have different type of t-test, one sample t-test, independent sample test, and paired t-test. Let us see one by one. For example, we do have this sample data, yield data, which is one sample should be analyzed in relation to hypothesized population mean. To do this, since the Excel built-in function requires two data range, we have to create dummy variables here. Dummy variables, at least 2 or 3 zeros. Once we do this, let us go to data and click data analysis here. If we can't see this data analysis here, go to file, go to option and click add in, and from Excel add in click go to. From this dialog box, check analysis ToolPak and then click OK, and it will be displayed here. Now click on data analysis and choose t-test to sample assuming unequal variance, because these two variable is assumed to have unequal variance. So select this one and click OK. Now enter the first range here, the actual data, and on the second range box enter the dummy variable and insert the hypothesized mean difference, that is 19, and check the levels because we do have selected this non-numeric variable. And once we choose output range location, it should be here, and click OK. This is output. We don't need the dummy column, we can delete it. As you see here, we have the important one is t-statistics and probability for one tail t-test. So you see, okay, and t-critical for one tail. These are the important for our case because we already have hypothesized sample mean is greater than hypothesized population mean. If the t-statistics is greater than t-critical, we need to reject null hypothesis and accept the alternate hypothesis. Or the other is, if the probability is less than 0.05, we need to accept the alternate hypothesis by rejecting null hypothesis. Okay? This is for one sample test. For two sample test, for example, we do have this one, the protected rangeland and unprotected pasture land. They are independent variable, independent samples, because they are taken from different experimental unit. So we need to follow the same procedure. Go to data and click data analysis. Now we have to choose either two sample assuming equal variance or two sample assuming unequal variance. To choose either of these two, we have to ensure that there is variance difference. To do that, we have to employ f-test for two sample for variance. Click here and click OK. Now input range 1 here and the second range, this one here. Now we have to give location for the output here and click OK. As you see here, the F calculated is less than F critical, so we need to accept null hypothesis. That means there is similarity. There is similarity between two variants. So we need to employ analysis of variance for unequal analysis of t-test for unequal variance. Let us go to here, t-test assuming equal variance, t-test to sample assuming equal variance. Click OK, and again choose the range and input the second range on the second range box, enter, then click OK. This is the output. This is the output as you see here. The t-cal is greater than t-critical for both one tail and two tail. Here we should consider two-tail test, because we have no ground to say either of the mean is greater than or less than the other mean, another mean. Okay, our important concern are here. So probability for two-tail test, if we consider all these, t-stat is greater than t-critical, and the probability is extremely less than 0.05. So protected pasture land have higher yield as compared to unprotected one. Okay. The other is paired t-test. If we do have such data, we do have 10 individuals here, and their performance before and after training is this one. Assessment performance result is this one. So we have to calculate the difference between these two. The result after training minus the result before training. Let us drag down the formula, and this is the sum and this is the average. So we have to square each difference. This is square, and click enter and drag the formula down like this, and the sum of di square will be sum of this all, be like this. Now sum of t square means this square, that is this square, and sum of the I square means this one. Just you can copy this one. And observation, number of observation, we can use this formula, count a formula, count a count a formula, and just select the value and click enter. We do have n. Now this over this means this is a correction term. This is a correction term. This divided by number of observation, and the variance is sum of individual observation square, this one, minus a correction term over n minus 1, that is this minus this value minus this or this one divided by n minus 1. N minus 1, that is 9. Okay. This one is minus 1. We have to close the bracket and enter. So the standard deviation is, we can use the built-in function, standard deviation for sample, and this observation, this is the standard deviation, or we can calculate also the square root of variance. Square root of variance. Square root of variance, this one, same result will be obtained. The standard error, which is standard deviation over square root of n. Our standard deviation is this one divided by square root of square n, that is 10, enter. Now TCAL means T calculated mean over standard error. The mean is here divided by standard error, that is this one. And T critical for one tail can be conducted equals T inf, T dot inf, and the probability is 0.05, and the degree of freedom is n-1, which is 9. Close and enter. To avoid the negative sign here, since we expect the performance of individual after training is greater than the performance before training, should be positive t-tail, right tail t-test. So to do this, we can use absolute value function, and finally close the bracket and enter. Probability, we can do the probability by writing t dot test, t-test, which RA1 is this one, okay. RA1, the second array is this one, comma, tail type is one tail, and the type is paired test. Test type is paired test, that is one. Close the bracket and enter. This is manual. But we can do this analysis using the built-in function. How to do it? Just go to data and go to data analysis and select paired to sample for me and click OK. Now input the range here, and for the second range input before training and enter, and check the levels because we selected the non-numeric data, this title, before and after training. And once we select the location for the output here, click OK. This is the result, as you see. This was manual. This have been calculated manually, but with the built-in function using this data analysis ToolPak, we calculated in short. As you see, t-stat is this one, okay? And for one tail test, the probability is 3.44 times 10 to the power of -6. That means less than 0.05, 0.00005. Okay. So by observing as t critical, t tabulated is greater than t calculated is greater than t critical, we can accept null hypothesis, alternate hypothesis. And also by looking on the probability, which is less than 0.05, we can reject the null hypothesis. This is the technique. For regression, I have uploaded the video. We talk about analysis of regression using Excel. You can look on that video. For today, thank you for your view. If you are new for my channel, please subscribe. Otherwise, like it, just click on the like button. Thank you. Share it for you like if you get it helpful. Okay. Have a nice day.